Hi everyone, welcome to your first lesson in algebra. Today we will be discussing the order of operations. The order of operations is going to be very critical in understanding many algebraic concepts throughout this year. Now you should have already learned the order of operations. The order of operations is a set of procedures that we use to simplify expressions. In the following examples, we will be using the order of operations to simplify numerical expressions. Numerical expressions are just a string of numbers separated by operations, so addition, subtraction, multiplication, and division. And to simplify these numerical expressions means to get them down to one value or one number. Notice I did not use the word solve. When we're working with expressions, we are not solving these expressions. We use the word solve for equations. Equations have equal signs. In numbers 1 through 9, we do not see equal signs. These are expressions, and we are simplifying them. So a review of order of operations. When we are dealt with a numerical expression, or just a general expression, we want to simplify it by first taking care of your parentheses and brackets. Parentheses could look like this, or they could look like this. They could also look like this. There's many ways parentheses can be demonstrated by, but these are the most common symbols that we use for parentheses. When we're completing our parentheses or simplifying them, we want to deal with the innermost parentheses first. As we simplify our parentheses, we will drop our parentheses. However, there are a few cases where we will not drop our parentheses, and that is if our set of parentheses is being raised to an exponent. Absolute values, which we will deal with in this lesson, will be taken care of in the parentheses step. Absolute values are not considered parentheses, but they will still be considered the first step in simplifying expressions. So after you have dealt with all the parentheses and the brackets, we then move on to exponents. Next, we move on to multiplication and division. We take care of multiplication and division from left to right. So if division is the very first operation, then we will deal with that before we deal with the multiplication. And then lastly, after multiplication and division have been taken care of, we deal with our addition and subtraction from left to right. So addition doesn't always come first. We need to see which operation is the leftmost operation. In the following, I have an example, and you can follow along with that example if you wish. If this helps you, go ahead and read through that. But you should have learned the order of operations. You should have learned this phrase, PEMDAS. This is an acronym that stands for the parentheses, exponents, multiplication and division, addition and subtraction. You may have also heard of the sentence, "Please excuse my dear Aunt Sally," which stands for PEMDAS to help you remember the order of operations. We are going to get started with some examples. Okay, we're simplifying the following numerical expressions, starting with number 1. There are no parentheses and no exponents. So we're going to jump straight into multiplication and division from left to right. So the only multiplication and division that I see is this 2 times 3. Notice how I'm rewriting the 6 plus 4 minus. And now I'm going to actually simplify the 2 times the 3 to get a 6. Now I move on to addition and subtraction from left to right. I start at the very beginning of my problem and do the leftmost operation, which is the addition. So I'm going to take care of the 6 plus 4, which is a 10, and then I rewrite that minus 6. This is how I'm showing my work. I'm showing my steps. I'm showing my thought process. You need to do this every time. Now I'm going to take care of the 10 minus the 6 to get my final answer, which is a 4. That is now fully simplified because I have it down to a single numerical value. Moving on to number 2. I'm first going to start off with parentheses. Since there are no exponents attached to these parentheses, when I simplify, my parentheses will go away. So an 8 minus a 3 is a 5, times this 3 outside of the parentheses, since there's no operation between the 3 and the parentheses, that is an imaginary multiplication. So it's a 3 times, and then a 3 plus a 2, which is a 5. Notice my parentheses disappeared. Now there's no exponents, so now I move on to multiplication and division from left to right. So I start off at the beginning of my problem, and I take care of the 5 times the 3 first, which gives me a 15. And then I rewrite that times 5. And then lastly, I'm going to do the last step. 15 times a 5 gives me my answer of 75. This is fully simplified because it is down to a single numerical value. Moving on to number 3. There is no parentheses, but there is an exponent. So we're going to jump into the exponent right away. I have a 48, notice how I'm rewriting everything, divided by, and a 2 to the 3rd power, you can use your calculator, or this is the same thing as a 2 times a 2 times a 2. A 2 times the first 2 is a 4 times this last 2 is an 8. So a 2 to the 3rd power is an 8. And then I rewrite the rest of my problem. Starting from the beginning of the problem, I do multiplication and division from left to right. So the division comes first. 48 divided by an 8 is a 6. And then I rewrite the rest of my problem. Now I start from the beginning. A 6 times a 3 is an 18. Rewriting the rest of my problem, I have one final step, an 18 plus a 5, which gives me my value, which is 23. All right, moving on to number 4. Number 4, I have 2 sets of parentheses. I'm going to start with the innermost parentheses first. So that's 6 minus 2. So I have a 4 times. When you simplify a set of parentheses, you can keep those as brackets, or you can change the brackets to a set of parentheses because my other parentheses are going away. So I've divided a 6 minus a 2 as a 4. So now I just have one set of parentheses. So I can change them to parentheses instead of keeping them as brackets, but it's up to you. I'm going to continue on simplifying my parentheses. Only this time I do have an exponent on the outside of my parentheses, so I'm not going to drop my parentheses. The reason why we don't drop is because if that was a negative 3 being raised to the 2nd power, it would matter whether that negative 3 was in parentheses or not. So we keep it in parentheses when there's an exponent on the outside. Now I'm going to take care of the exponent. And I'm going to drop my parentheses, and that 4 is really being multiplied by the 3 squared, and a 3 squared is a 9. Lastly, I do the 4 times the 9 to get my final answer, which is a 36. Now number 5 is a little bit different, because number 5, technically, there are imaginary parentheses around the numerator and the denominator. So we need to simplify the numerator and the denominator separately, and then we can do the division. So, starting with my numerator, I'm going to first take care of the exponents. Remember, a 2 to the 3rd power from number 3 was an 8. Minus a 6 times a 2. And if it helps, you can keep the numerator in parentheses, even though technically they're imaginary and they're not really there. That's up to you. A 3 to the 3rd power is a 3 times a 3 times a 3, which is a 27. All right, now in my numerator, I'm going to take care of the multiplication, which is the 6 times the 2, In my denominator, I'm also going to take care of the multiplication, which is a 5 times a 3. So I wind up with an 8 minus a 12 all over a 27 minus a 15 minus a 2. Next, I'm going to take care of the numerator. The 8 minus the 12 is a negative 4. And then (27 minus 15) in my denominator, which is going to be a 12, and then I still have that minus 2 in the denominator. So now I still need to simplify the denominator. I have the negative 4 in the numerator, and then a 12 minus a 2 is a 10 in the denominator. Now we're going to leave our answer as a fraction. However, we're going to simplify this fraction. A negative 4 is divisible by a 2, and a 10 is divisible by a 2. Negative 4 divided by a 2 is a negative 2, and a 10 divided by a 2 is a 5. In algebra, we leave things as fractions. Fractions are our friends. We keep them as fractions, or keep our answers as fractions always. So negative 2/5 is your answer. Moving on to number 6, we're going to start with multiplication and division from left to right because there are no parentheses or exponents. So I have a 24 minus an 18 plus a 6 divided by 3. I'm now going to do the 6 divided by 3. So I have a 24 minus an 18 plus a 2. I'm now going to take care of the 24 minus the 18, which I get a 6. And then I have the 6 plus 2, which gives me an 8. All right. Moving on to number 7, we're going to do our parentheses first. 2 plus a 7. I'm going to drop those parentheses because there's no exponent on the outside. It's a 12 times a 9, and then minus a 24 divided by 12. Starting over from the beginning, I'm now going to do the 12 times the 9 to get a 108, minus 24 divided by 12. I'm now going to do the 24 divided by 12 to get a 108 minus a 2. And then lastly, I do the 108 minus a 2 to get a 106. Okay, so completing number 8, we're going to deal with the parentheses first. And since there's an exponent on the outside of parentheses, we're going to leave the parentheses there. A 42 minus a 45 is a negative 3. And then this is squared. So now we're going to take care of the exponents. We have a 3 to the 4th power, and then we have this negative 3 to the 2nd power. Now a 3 to the 4th power is the same as a 3 times a 3 times a 3 times a 3. So that's an 81. Now we got to be very careful with the next exponent because the next one is really a negative 3 times a negative 3, which is a positive 9. But there's a minus sign on the outside of the parentheses, so that's why there's a minus sign here. Now we jump back to the beginning. We do the division, 81 divided by a 27 to get a 3. And then I can do my final step, which is that 3 minus that 9 to get a negative 6. Moving on to the last problem, I'm going to take care of my absolute values and my parentheses. Since there's an exponent on the outside of my parentheses, I will keep the parentheses there. So I wind up with the absolute value of negative 8. And then all of this. All right. So now I'm going to take care of this absolute value of negative 8 and the 1 to the 3rd power. Absolute value of a negative number is a positive number, so I get a positive 8, but again, this negative was on the outside, so that negative remains. All right, I'm going to have you finish this problem off from here. you should wind up with negative 14.